For the same above example, let us look into a Gantt chart for preemptive SJF scheduling. Preemptive SJF is also known as shortest remaining time first. Example, it is same example I am considering now. At time 0, Gantt chart look like this. So no process is present right now. So at the time 0, according to the given problem statement, the process P1 appears, which is having a burst time 10, and since there is no process, P1 is scheduled for CPU. Then P1 starts execution. Once P1 starts execution, at the time 3, another two new processes arrived. They are having the burst times 5 and 6, and the remaining time of P1 is 7. P1 is executed 3 milliseconds already, and remaining time is 7. Now when you compare all these remaining times, the process P2 has least burst time, so preempt the P1 process and then schedule the P2. Then P2 is scheduled for the execution. P2 starts execution. Then at time 5, one more process is arrived, is P4, which is having a burst time 4, and remaining time of P2 is 3. It is executed for 2 milliseconds. At 5, all the processes have been arrived. When you compare all these four processes, the remaining time of the process P2 is lesser compared to all other processes. So P2 is allowed to continue its execution, and P2 completes the execution at 8, so its burst time is over. So the remaining times of all the processes are given like this: P1 is 7, P2 finished, P3 remaining time is 6, P4 remaining time is 4. Next, out of these three processes, the P4 is having the least burst time, so P4 is scheduled for the execution. Then the P4 finishes its execution at 12, so it is having a burst time 4 and started its execution at 8 and then finishes at 12. Then remaining times are given like this: P1 is 7, P2 is finished, P3 is 6, and P4 is finished. Now when you compare P1 and P3, P3 is having lesser time, so it is allowed to execute. Next, P3 is allocated a CPU and it starts execution from 12 and finishes at 18. So once it is finished, so the remaining uh, time of P1, P2, P3, P4 are given here. P1 is 7, P2, P3, P4 are all finished, and next no process is there, so except P1. So P1 is scheduled for CPU and it finishes at 25. So the final chart of SJF, preemptive SJF, is appearing like this. So all processes finishes their execution at 25. So the problem statement chart is given here, and the same calculations are done: turnaround time and waiting time. Turnaround time is calculated as like this: completion time minus arrival time. Waiting time is calculated like this: turnaround time minus burst time. So let us look into the P1, which finishes at 25 and appears at 0. So turnaround time is 25. For process P2, it finishes at 8 and appears at 3. So its remaining turnaround time is 5. And P3 appears at 3 and finishes at 18. So its remaining turnaround time is 15. And process P4 appears at 5 and finishes at 12. So turnaround time is 7. Similarly, waiting time is calculated, uh, which is nothing but turnaround time minus bus time. P1 bus time is 10, so its waiting time is 15. P2 bus time is 5, so its waiting time is 0, because it appears at 5 and gets the CPU at the same time. So like this the calculations are done. The final calculation goes in this way. The average turnaround time is 13 ms and average waiting time is 6.75 ms. Thank you.